Okay, so we'll wait another minute and then we'll get started. Upload Desmos. Okay, so we worked on 1 through 5 on Friday, and I just want to look at them briefly. I'm not going to go through them, but I just wanted to take note at how I think every single example we've done so far, um, you could have used technology to assist yourself or even just outright solve the problem. So for the first question we did, you were just asked to figure out which one of these 4 choices results in this graph. So yeah, you could have just used Desmo straight away and plotted A, B, C, and D, and then examined which one of them, resulted in this graph. So it's just visual. Okay, you can graph all 4 and see which choice produces this one, and that's the answer. And B produced this. So simple as that. Two was just an absolute value equation, which again, you could solve by dropping in the absolute value of 3x minus 1, dropping in x plus 5, and looking to see where they intersect. And as simple as that, 2 seconds, you know that x is negative 1 and x is 3. Or you could have done the algebraic approach here, which is much longer, but another way of doing it. So you had a couple of ways you could do this. And by the way, one could have been done algebraically too if you know the equation for for the horizontal and vertical shifting, which is actually in your notes. It's lessons 1.2 and 1.3, I believe, and that's attached to Google Classroom. They're there, okay? And I believe the same thing is true for example 3. Example 3 was just like question 1, except instead of being a absolute value, it's a quadratic, and you're asked to see which one of these 4 things produced this curve. And again, if you could either A, put all 4 choices into Desmos and see which one gives you this graph, which we did, which was A, or if you understand the definition for vertical and horizontal shifting, you could use that as well, and that'll tell you, what it is algebraically. That was the other way of doing it. Question 4 was again another one where you can use the computer, but you had to use Desmos matrix instead of just regular Desmos, and that was solvable by turning what you were given into an augmented matrix. Okay, turn it into an augmented matrix, put that into Desmos, and then you can evaluate by using RREF, which is the reduced row echelon form, which will solve for the 3 values. Tomorrow, I'm going to run through this example again, but I'm going to do it algebraically because I think one of the assessment questions will ask you to solve the system algebraically. So I want to make sure I go through how to do that. So you could still use the computer to get the answer, but you're going to have to illustrate the work. So tomorrow I'll handle that. Then question 5, we did Friday as well. And question 5, they want to know, how do you model this data? So what I did, and you could have done this strictly on the computer too, I believe. What I did was I plotted all the points. I plotted negative 2, 5. I plotted negative 1, 4, 0, 3, 1, 4, 2, 5. I just plot the points. And when I plot the points and connect everything, I have this. And based on what we see, we could tell it's absolute value. Um, and then we're looking to see which one of these gives us this diagram. And not for nothing, we know it has to be absolute value because all 4 choices are absolute value. So I figured that. And C results in this graph. Okay. You can put these choices into Desmos, and you'll see that C gives you a picture of what it is that you have based on the points. Okay. The other way of doing it, which I didn't show you, is you could substitute these x values in, all right, and make sure that when you put these x values in, it results in the y value on the right. So I'm not going to do them all, but for example, if you put -2 in there, okay, if you put -2 in here, the absolute value in -2, so if we try x equals -2, we get the absolute value of -2 plus 3, which is equal to 2 plus 3, which is 5. Okay? If we put -1 in there, the absolute value of -1 is 1 plus 3, and that's equal to 4. Okay, you can do this for all the values. I promise you, if you try them on your own, they're all going to work. So statement C, every single x value produces the proper y value when you apply C. That's not true for A. It's not true. If you try to put -2 in here, I'll show you why A is incorrect. -2 plus 3. Okay, we're putting -2 here, right? We're supposed to get, we put -2, we're supposed to get 5. We're not going to. -2 plus 3 is equal to the absolute value of 1, and the absolute value of 1 is 1. So this is wrong. It does not result in the 5 we're supposed to get. Okay, and these were all failures as well. We didn't even learn how to do the ones with y. So C will work for all the values. C is definitely proper. Okay, so that's the stuff we did Friday. That's everything that I talked about Friday, and now I'm on example 6. So now we're really getting started, I guess now. Okay, this is the first question where I don't know how helpful the computer will actually be because it's conceptual. It's not really something that you're going to compute. It's something that you have to understand the concept. So the graph below represents f of x. So fine, there's my function. Okay, which graph represents absolute value of f of x? So now we need to know what absolute value is, okay, what it does. So it's very important to understand what absolute value does. Absolute value, right, based on our knowledge, whenever you have absolute value of something, your answer always has to be something that's greater than or equal to 0. You're never going to take the absolute value and get a negative. That's impossible. So your answer is always going to be 0 or larger. Now, if you go back to earlier in the year, we learned that f of x is another way of just saying y. Okay, it's another way of saying y. It's the same thing. So basically, f of x, because of this, has to always be bigger. The outcome has to always be bigger than 0, which means y has to always be bigger than or equal to 0. Okay, because f of x and y are the same thing. So, in other words, no matter what I put in here, my answers are going to be positive answers. So, when I think about it, this is the y-axis, and positive y values are up here. Okay, positive y values are up here. So anything I put in terms of x, my absolute value is going to spit out something that's positive. It's going to spit out something that's above the x-axis because positive numbers for y are the numbers above the x-axis. When you go down here, you're talking about negative y's. Well, that can't happen because I'm dealing with absolute value here. It's got to be positive. So I'm going to be looking for an answer choice in which everything is completely up here. It's got to be above the x-axis. And if you look at the answer choices, there's only one answer choice that could possibly make sense here. Anybody want to take a wager at which one could possibly make sense? There's only one choice where the graph is completely above the x-axis. Anybody want to vote on it? Which one do you think is completely above the x-axis based on choices A, B, C, or D? So if you look at A, is A completely above the x-axis? Is B completely above? Is C completely above or is D completely above?
It's C.
C?
Yeah,
Okay.
C.
Yeah, I agree with that. C C is completely above the x-axis, right? A has parts where it's underneath. That's negative. That's impossible. And I'll highlight it. This is underneath the x-axis. That can't happen. It's got to be absolute value's got to be above. This has parts negative as well. This little V right here, right? That region there, you're negative. That can't happen because absolute value we know produces a positive. So that can't happen. And here, again, you have some negative region here as well, and that can't happen because we know that absolute value results in something 0 or larger, and this is not. This is negative, so it's not acceptable. So only C makes sense. Only C makes sense. Um, Now there's a reason why algebraically, if you now what I'm about to do is not necessary. I'm forcing this just to show you that the computer could be used, but this one was easier just to do conceptually. There's not much to really write down here. It's just knowing that the absolute value produces positive numbers. If you know that, then this is easy. If you don't know that, well, then it's not so easy. Um, I'm gonna give f of x life. I'm gonna make an equation. I'm gonna say f of x is 2x minus 5. So I'm making this up, okay? It could be because this has a positive slope and a negative y-intercept, but no worries about that. So let me graph 2x minus 5, and then let me graph next to it 2x minus 5, absolute value. So let's see what happens if we start out with f of x being this, and then we make it an absolute value, okay? And let's see what happens. So I'm going to illustrate this graphically again. This is not something I would do on an exam. I'm forcing the computer just to show you that it can be used, but it's probably not the best tool for this problem. It's probably easier just to do it conceptually. But anyway, let me just illustrate it. 2x minus 5 and absolute 2x minus 5. Let's take a look. Okay, let's take a look. Desmos should be opening. Hopefully you can see it at this point. Okay, it looks like you can. So I'm going to look at 2x minus 5. That's the original function. And that sort of looks like the function that I gave you, right? That sort of looks like just a line. It looks about right. And then I want to compare that with the absolute value of 2x minus 5. Let's see what happens. 2x minus 5. And you can see, right? Okay, 2x minus 5 is the new item. It's the absolute value of the original. I'm going to take the original away. And you can see now, right, that this graph is completely above the x-axis because of the absolute value symbol. Okay, I can see it now. It's taken the part that was negative, this piece down here, and it's now pushed it up here. Okay, and there's a reason why that happened because of the absolute value. It left, and I'll put the original graph back for a minute. It left the original, the green, where it was, and it took the part that was beneath the x-axis and made that positive, because that's what absolute value does. It leaves the positive stuff positive and turns the negative stuff into positive stuff, right? That's how absolute value works. So I'm not surprised by this. This is what I would expect to have happen. What I expect to have happen has happened. So no surprises there at all, actually. Um, so basically, what it's done is it's taken this piece that was negative and pushed it, okay, and pushed it up here. It's moved it up. Okay, so all the negative points kind of get moved to the positive region. That's because of the absolute value. Okay, that's because of that. Any questions on anything here? Anything at all? Oh, all right. So hopefully now you can hear. She didn't know the meet started because it was her device was muted. Um, I'll try to go back over the example afterwards, but all right. Anything on this for now, or are we okay? Anything? Okay. So not too hard. It's just if you know what the absolute value is, you're solid. If you don't know the absolute value, then then it's a little bit problematic. So you definitely want to know what the absolute value means. All right, so let's see for the next example. Okay, this one, very simple. The solution set of which inequality is represented by the accompanying graph. So they gave you the answer. This is what you want to have happen. And they want to know which of these inequalities, which of these four choices, they're all inequalities, will lead to this picture. Okay, so which of these will lead you to end up with this diagram? This is for sure a Desmos question. I do not want to have to sit here, right, and then manually solve A, B, C, and D, right? It's like doing four questions. So I don't really want to do that. I want to take advantage of the technology, and I can quickly um, utilize all four of these choices. And I'm looking for the choice that results in -5 and 9, right, as my critical points. So I'm looking for -5 and 9. And just as important, I need the shading to be left of -5 and the shading to be bigger than 9. Okay, so I want to find solutions at -5 with shading to the left and 9 with shading to the right. In other words, I'm looking for -5 and 9, and the shading goes on the outsides. That's what I'm looking for. So one of these four choices is going to give me this. Okay, so I'm going to put each of these choices into Desmos and then examine which one gives me the proper picture. Okay, so I'm looking again for -5, left of -5, and right of 9 for shading. So let's do that. Let's put these into the computer and see what happens. It's a fairly easy question when you have when you have access to technology, because there's not really much for you to think about. You just got to make sure that you get the right diagram. So I'm going to put these things in. Okay, the first one was x minus 2 is less than 7 with an absolute value. X minus 2 is less than 7. Okay, I got negative. This is incorrect already. So I need -5 and 9. Well, I have -5. Great. -5. That's right. I have 9. That's right. So my points are right. -5 and 9. I got the right points. And the circles are open like on the diagram because these lines are dashed. Solid lines would mean closed circles. Dash lines indicate open circles. So I have dash lines at -5 and 9 indicating open circles. I'm happy about that. But my shading is in between. And that's not what the test had. The test has the shading going to the outside. So this is the wrong choice because the shading is going the wrong way. It's got the shading in the wrong place. So it's not going to be answer choice A. So I can rule out answer choice A. And now I'm going to try answer choice B. Answer choice B says 2 minus x absolute is greater than -7. And if I do that, the whole thing lights up. And so this is definitely not the answer because the whole thing is lighting up. And the reason why the whole thing lights up is because absolute value is always bigger than a negative number, right? Everything is bigger than anytime you do absolute value, you're always going to be bigger than a negative. So this would be everything. So I knew before I even put this into the computer that it was the wrong answer. But if you forgot that, it's okay. Put it in the computer and you'll see for yourself that, hey, this is not the right answer. Everything's highlighted here. That's because every single X value will work. The graph doesn't show that. So this is not the right answer. So B is incorrect. Let me just cross B off. Now C says something like, or says exactly, it says exactly X minus 2 is greater than 7. Okay, so let's take a look at this one. Um, It looks like I'm just going to zoom out a little bit. It looks like we have -5, right? Like we want, and 9. So I got the right points, -5 and 9. There they are. Dash lines, which indicate open circles at -5 and 9. So that's good. And the shading is on the outside. In other words, I'm shading left of -5 and I'm shading right of 9, which is what my test looked like. The shading was on the outsides. working with -5 and 9. So this one matches what I see in my exam paper again, shading left of -5, shading to the right of 9. So if we go back to the test paper, toot, 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 let that load up. Okay, it should be loaded up. I have shading to the left of -5 and to the right of 9. So this one does make sense. Answer choice C works. Okay. Now, if you check D, I promise you it doesn't work. You're going to see, if you try to do D, you're going to see nothing because absolute value can't be, has to be positive. It can't be less than -7. So this one you won't, it'll just be a white diagram. You'll see nothing. So this is wrong too. For those of you who want to do the problem algebraically, I can't go through all the wrong ones, but I'll go through answer choice C just because of time constraints. So if you wanted to work out example C, which is x minus 2 is greater than 7, we learned that to do absolute value with inequalities, you still, just like equations, you have to make two statements. One is x minus 2 is greater than 7. Anybody want to give the alternative one a shot? Anybody remember how to do it? If you don't remember how to do it, it's okay. I'll do it, but I want to see if anybody can remember how to do it.
It's x minus 2 is greater than -7.
Almost perfect. Okay. So this one was greater than
That's what
the
I said.
inequality, right? Almost perfect. You have to change the sign too, right? So it's both things. You change the sign of the number to -7, which was correct, but also you have to change the greater than to a less than.
Oh,
So
okay.
yeah, when you do the alternative, it's two things that change. It's the inequality symbols direction and the signs. So it's both, okay? And yeah, this is actually in notes. If you go back, I know it was a while ago that we learned this, but yeah, that's in there. And then once you do that, then it's just pretty easy. You're just solving for x. So I know that you guys can knock this out like no problem. You can just add 2 to each side to get x by itself. Of course, these cancel, and you can see then that x is greater than 9. So x is greater than 9. You can see that here. Here is 9. Things are greater than 9 going this way. So algebraically, this is making sense. X is greater than 9 is out here. Let me quickly solve this one. Um, plus 2 to get x by itself. And these are pretty easy to solve. And x is going to be less than -5 because 2 minus 7 is -5. Okay, x is less than -5. There's -5. Things are smaller on the left-hand side, so shading goes to the left. So this checks out as well. So we can see that answer choice C is the appropriate choice because if you were to graph the solution for what you see, you would get what you have up here. Okay. So they just did it backwards. I normally give you this, and then you normally give me the number line. But this time they gave you the answer and they gave you four possible questions and asked you which one results in this. So it was just faster to use Desmos, I think, than rather than having to work all these out. Not that they're hard, but it's a little bit time consuming and can be a little annoying. And using Desmo is just going to be faster for this one. But it's up to you. You do it however you want to do it. If you want to work out all four algebraically, you can. And eventually, when you get to C, you'll see C works. So, all right, that's pretty much it for 7. Anybody have any questions on 7 before I go on to 8? I can't think of anything else I could add to 7. I solved it both ways, graphically and algebraically, so I can't think of anything else. Anybody have any questions? Okay. Um, so with that, then let's take a look at number 8. Okay, we haven't done 8 in a little while. Write an equation that represents the line passing through 5, 4 and -5, 0. This is an important question because you should know how to be able to write the equation of a line. And there were three tools that came in this lesson. There were three tools. One of them is y equals mx plus b. This is how I normally write the equation of a line. I like to do it this way. There's another equation, which we learned y minus y1 equals m parenthesis x minus x1. Now, I use this equation, just not in this form. What I like to do is convert this equation into m equals y2 minus y1 over x2 minus x1. These basically are the same thing. What happened here was, if you think about it and you put this over 1 and put this over 1, you can cross multiply and you'll get this equation here. So technically, this equation and this equation are the same. It's just the manipulated form, okay, of each other. They're the same thing. So I just prefer using these two. I like to use these two. I'm going to use this and I'm going to use this. Do you have to do it this way? No, you do not. Okay. It's up to you. You can use this form if you want. I just prefer this form. Why is it that I prefer this form? Well, when I write the equation of a line, um, I would like to have two things known. I would like to find the m value and then the y-intercept. Once I know m, it's very easy to find b, but I have to find the m first. Okay. So I'm going to do my work to find m. And finding m, though, is not bad when you have 2 points. Okay. I can call this coordinate x1, which means this would be y1. And then if that's the case, I can call this point x2, which makes this y2. How is that helpful? That allows me to take advantage of this formula and easily solve for the slope. So I can just do y2 minus y1, which in this case is 0 minus 4. And in my denominator, I can do -5 minus 5 because x2 is -5 and x1 is 5. So I can do that. And now I just work this out. It's really simple. 0 minus 4 is -4, and -5 minus 5 is -10. And I don't like having a negative over a negative like this, so I know that whenever I have a negative over a negative, it's a positive. So m equals positive 4/10. And you can leave it like this, or if you want, you can reduce it. I think 2 fits into both of these. 2 could go into 4 twice, and 2 could go into 10 5 times. So if you want to reduce 4/10, you can feel free to reduce it to 2/5 if you want. If you leave it as 4/10, I don't really care. I mean, it's probably best to reduce the simplest form. If it's multiple choice, only the reduced answer will appear. So it's a good idea to reduce it. But if you leave it as 4/10, you're not going to lose anything from me. All right. So I just reduced 4/10 to 2/5, and that's my slope. So if I go back over here now, I know that y equals 2/5 x plus b. Okay. So I'm almost done. I just want to solve for b. Solving for b is easy. You can just substitute in for x and y and use that information to solve for b. So again, you could substitute into x and y and use the information you get to solve for b. Um, that gives you the freedom to choose either this point or this point. I'm just going to choose this point, and it's up to you. You can choose this point. You'll get the same answer. It doesn't matter. Once again, whatever point you choose, it won't make a difference. It's irrelevant. You're going to get the same answer regardless. I'm just choosing this one because I don't like having a negative. So I'm choosing this one. My x is 5, my y is 4. My x is 5, my y is 4. My y is 4, and my x is 5. I have everything I need to solve for b. All right. I have 4 equals, I'm going to do 5 times 2, which is going to give me 10. And then 10 divided by 5 is going to give me 2. And then from here, to get b all by itself, we could just kind of subtract 2 from each side to get b alone. Of course, these cancel. And 4 minus 2 is 2. And now I know my b value is 2. So I know my m value. I know my b value. I just want to rewrite this equation with m and b replaced. So I know that y equals, well, m we knew already, it was 2/5. So 2/5 x, right? Plus b is 2. All right, so there's my equation. Y equals 2/5 x plus 2. So just some notes on this. Well, you need to know this equation and this equation at least, right? If you know this one, you can figure this one out. It's just using cross multiplication, but I think most students like knowing having this written down and having this written down. To do this problem, it's pretty easy. The first thing you want to do is find the slope. And then after you do that, you want to find the y-intercept. Okay, but you have to get the slope first. Once you get the slope, it's easy to find the y-intercept. All right, and then you just write it in this equation. Now, is there a way to check to make sure I didn't make any like careless mistakes? There actually is. I can plot this line in Desmos, right? And then make sure these points are on the line. Because remember, the question asked, write an equation that represents the line that passes through, it has to go through 5, 4, and negative 5, 0. So this line had better include the coordinates 5, 4, and negative 5, 0. It should include them. That's my claim. I'm claiming that this line here includes these points. Well, how can I be sure? Well, I can be sure by graphing this and making sure that these points are there. So I'm going to graph this. Just what I'm doing now is just to prove to you that I did it right. So it's not essential. It's just I'm checking it. I want to show you that I did it right. So let's make sure. So I have to graph this and make sure these points are there. And fortunately for me, I have access to Desmos, and so do you. And we can use this now to graph the line. The line we're trying to graph is 2/5 x plus 2. So 2/5 x plus 2. And it has to include, what were the coordinates? They were 5, 4, and negative 5, 0. 5, 4, and negative 5, 0. Well, look at this. I know for a fact it's got negative 5, 0 on it. So there's negative 5, 0. It's on my line. And the other point's 5, 4. Or let me make sure. The other point's 5, 4. Okay, so 5, 4. So 5, let's make sure. And we can see that 5, 4 is on the line, okay? 5, 4 is there. 5, 4 is part of my line. So I have both negative 5, 0 and 5, 4 on this line. So I know my equation is correct. This line passes through both points, so we did it right, okay? So that's just like a check. You don't have to use Desmos for this part, just to make sure you did it right. So since I'm doing instruction, I want to prove that we did it right, and we did. And that's it for this one. We just bring it back to the notebook. Okay, so there we go. There, we answered 8. Um, any questions on this one at all? Anything at all? Anybody? Are we okay with how to handle writing the equation of a line? We have to find the m value using y2 minus y1 over x2 minus x1, and then after we find that value, we go back into mx plus b, and then we choose a point, and then we can find b, and then that's it. Once we find m and b, we got everything done. Any questions at all? Anything at all?
Mr. Peasy.
Yes.
So when we take the exam, we can use Desmos.
Yeah, you're actually it's meant for you to use Desmos. So what I'm going to ask that you do, either you have two options, right? Because you're going to be using Desmos for like at least half the questions, probably more. Probably like two-thirds to three-quarters of them, probably three-quarters of them. So 75% of the questions are going to be done with Desmos. You have two choices. Either A, you can make a rough sketch, right? Which is fine. I know it's not going to be perfect. Yeah, we're not all artists here. That's fine. Just so I can see what you did. Or B, you can actually clip Desmos if you want. Like you can clip the pictures and then import them. Some people have a harder time doing that. So I know some people are comfortable doing it because I get homework back when people actually clip the art, which is really, it comes out great. But if you are having a hard time doing that, then just make a sketch. What I've been doing is making a sketch, right? You see when I do it, I just sketch it. So that's fine. Anything that allows me to see what you did is fine. All right. It doesn't have to be perfect if you're sketching it. It just has to represent what's happening. Okay, that's all.
Okay,
Okay.
Mr. Minchi.
Yes.
Oh, sorry, my
Yes.
issue. But are you like taking a screenshot, or is there a way on the website where you can like take a like a graph and submit it in something another file? Because I took a screenshot. I didn't know you could do it another way.
No, the screenshot's fine. Do this. The
Oh,
screenshots works fine. That's perfect. Just keep doing what you're doing.
all
Okay.
right.
There's a couple of ways of doing it. The screenshot works fine. So you can keep doing
Okay.
it that way. That's perfect. All right. The screenshot's actually easier for than having to sketch it yourself for sure. Right. Because sketching it yourself is extra work for you to do. And then you're writing with, a mouse or I don't know, whatever you're writing with. It's not so comfortable. I'm writing with a mouse, so it's hard for me to make things perfect. So if you can take a screenshot, fine. If you have to sketch it by hand, then do the best you can. Anything that allows me to see what you did will be fine. Okay. Okay. All right. So that's really all there is for that. This one is good. Now number nine. So this is an example of something where we're going to use Desmos at number nine. This one I didn't really use Desmos. It's like the first example. It's the first example really where I didn't use it. I didn't use it on six either. So far for one, we used it. For question two, we used it. For three, we used it. For four, we used it. For five, we could sort of use it. Six, I think it's more conceptual, so no. Seven, we used it. And eight, not really. I use it to check, but I have to know what I'm doing. So most of the examples, yeah. This is another example of where we're going to use it. Given the equations y equals x squared and y equals negative x plus 5 squared minus 6. Describe the composition of transformations performed on A to get to B. In other words, how are we going from here? How are we getting from A to B? Now, there are two ways of doing this. One is if you just know all the rules, right? Like if you know the reflection laws and you know the translation laws, then you can just look at it and figure out what's going on. But many people might not. And that's fine if you don't remember them. It's actually okay. Because what you can do is we can actually use Desmos. We can graph this, and then just explain what we see. So we can make this problem visual, which is a good way of doing it, right? So we can make this problem into a visual question and answer it based on what we see. All right. So let me do that. Let me graph both of these x squared and this, and then we're going to answer based on what we see. Okay, so let's go to the Desmos, and I have to plot two things here. I have to plot, I think it's x squared is the first one, and I know how that looks. That's just the parent function we learned in like the first week of class. And the other function is negative x plus 5 squared minus 6. Negative x plus 5 with a squared on the outside minus 6. Let me zoom out a little so I can see that thing. Okay, so here's what I have. The green one is A, and the blue one, or bluish purple colored one, is B. Hmm. Anybody want to just briefly talk about what? So somebody want to tell me what they say? What happened? What's happened? How? Yes.
Reflection over x-axis and then 6 unit down.
Yes, I agree with that. Reflection over the x-axis, 6 units down. Anything else?
And 5 units left.
That's correct. So it's reflected over the x-axis. I agree with him, and then it's shifted two ways. It shifted left 5 units and down 6 units. If you write exactly what he said, that's a full credit response, okay? If we say it's reflected over the x-axis, shifted left 5 and down 6, we got all the points. So let me do that. I'm going to say that it's uh, reflected. I'm going to bring you back to the notebook in a minute. Reflected in the x-axis. Then it was shifted 5 units. Right, you can see it left and also shifted 6 units down. 6 units down. Okay, let me bring you back to notebook. So you can see that it's reflected over the x-axis. It's moved 5 this way and down and 6 this way. Okay. 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 So hopefully you can see my writing now. And I've just stated basically what we saw, right? It's reflected in the x-axis. It shifted 5 units left and then shifted 6 units down. This is full credit right here. We have all the points. Now, for somebody who wants to do it algebraically, and it can be done algebraically, if you know y equals x minus h squared plus k, all right, we know that h, I'm going to abbreviate here, h is a horizontal shifting, and k represents vertical shifting. All right. So what's happened is, well, first of all, the negative on the outside, this negative causes the reflection in the x-axis. So this negative, the negative causes the reflection in the x-axis. Okay. That's this. So that's the first thing we see. Then we know that H represents horizontal shifting. Horizontal shifting is annoying. When you add, it moves it to the left. When you subtract, it moves it to the right. Everything is backwards at horizontal shifting. This is in your notes. It's section 1.2 and 1.3. So since we're adding, right? It's going to move it left. We're adding to X directly. So for H, we're adding to X directly. It's going to shift it 5 units left. Okay. So the fact that we're adding 5, okay, the fact that we're adding 5 is why it's shifted 5 units left. And then the K, the number on the outside, I like doing the vertical. I taught you vertical shifting first. I taught you vertical shifting first because it's easier to understand. When you add to the entire function, it moves it up by k units. When you subtract k, it moves it down by k units. So we subtracted 6. We subtracted 6. That's going to push the graph down 6 units. Okay? So once again, the negative caused the reflection. Adding 5, which is in the H position, will move it left or right. In this case, left because you're adding, left 5 units. And adding to the whole function pushes it up, subtracting pushes it down. We subtracted, we pushed it down. Now, if you don't remember all this, that's fine, right? You have a picture that illustrates what happened. Okay, so if this was my test question and I can't remember this, right? Let's say, oh no, I don't remember this thing. That's fine. I don't panic. I know that I can just do this. I can say, okay, um, I know that the parent function looks like this. I'm going to draw that for the greater. Is x squared. So I give the parent function, and then I just draw what I saw in terms of the reflected function. It was like this. And I noticed that its vertex was -5, comma -6. If I do this, if I put my little sketch and then this, I get full credit. Okay, because I'm showing the grader that what's going on. I see it's reflected. I see it shifted left 5. I see it shifted down 6 units. So I'm showing the grader everything he or she would need, and that's full credit. So the alternative is to do it algebraically, but some people like it this way and some don't. So it's kind of up to you. You can either do it graphically, or if you want, you can use method 2 and just do it algebraically. It's up to you. Um, Let's take a look at the last one, just so I'm in the same place in my other class. This one will be quick. I think it's calculator related. Solve the inequality, this thing for x. Graph the solution on the line below. So at the last minute, okay, rather than doing algebraically, I'll show you algebraically tomorrow. There was no time in the other class either. I'm going to get the answer to this with the computer. I want to solve this inequality, so I'm going to put this into Desmos. Okay, I'm going to put this into Desmos, and I'm going to get my answer. So let's do that really quick before we go. Okay, I'm going to open Desmos back up, and please, if you're having trouble using Desmos and you need to speak to me, send me an email, and I'll find time to help you because it's such a critical part of this course. The function was -3 on the outside, and then absolute value. Then it was 6 minus x, 6 minus x. Oops, that went in the wrong place. It should be on the inside, 6 minus x. And then I believe it was less than -15. Okay, so I actually have values. The reason why this one works out, even though it says less than negative, is because this absolute value is not isolated. You have to divide it first. So yeah, this one's not as easy to figure out without actually doing the steps. Okay, um, so let's see. The critical points are. Let me zoom in a little bit. It looks like one, not a little bit, 1 and 11. So 1 and 11 are the critical points, and the shading is going away. So it's 1 and 11. And the circles at 1 and 11 are open because these are dashed lines. So I have to put circles at 1 and 11 and make the shading run to the outsides. Let me just do that really quick, and then we're done. 1 and 11, 1 and 11 with the shading on the outside. So let's put 1 here, put 11 here, open circles because Desmos had dashed lines there, and the shading was on the outsides. So we can see it was like this. And that models exactly what we see in the calculator. Just make sure you have your points labeled and the circles are open again because they were dashed lines. Had the lines been solid, the circles would be shaded in, but they weren't, so it's like this. And that is pretty much it. Are there any questions on that last one? I'll look at it again tomorrow. I'm sorry I rushed through it because I'm over the time. So tomorrow we'll look at this one again, and then we'll do a question with the 3 variables. We solve it by hand, and then maybe 1 or 2 other things just to review, and that's going to be it. The assessment will be Wednesday. Okay, so tomorrow's the last day of review. I'll try not to teach the entire period. I'll try to leave there some time for you guys to ask me questions, and I'll look at any specific things that you have. All right. So that's all I have today. If you have any problems, please email me. If not, enjoy the rest of your day. And I'll see you tomorrow. Be safe.
Bye.
Bye.
Bye, Mr. Busy.
Bye, guys. See you tomorrow, man. See you tomorrow.
Mr. MPC,
Yes,
I didn't get the email that you said you were gonna send me
I
about
did.
the.
You didn't get
You
it?
said
Yeah.
no, I didn't.
Which one are you looking for now? Now I got confused. For me to help, extra help, or for something else? I did send it on
No,
Friday.
you said that you were gonna send me. You had to send me an email about how to get in the meeting and stuff because I couldn't get in the meeting.
Yeah. That okay. All right. So I spoke to. Let me try to send it now. Okay. I spoke to the tech person. Tell me if you get a link from me. All right. Give me a second to open it. Is it just for the class every day or for the extra help class?
Yeah, yeah, the class every day.
Every day.
Yeah.
Let me see. I can try to, because I think I have you in there now. Let me see.
I still be using the link that you sent me
Yeah,
the first time. That's the
just
link I
keep using that link. It's okay. You're in the class. Keep using